Hey guys, it's Brent with Lykins Motorsports. What you're seeing there is a 418 cubic inch Windsor, so a 351 Windsor, small block Ford. This is a very stout combination, and I did this particular engine a couple years ago and dug up some pictures and a dyno sheet this morning and just wanted to share it with you so you can see what kind of power and torque is available from this combination. So this starts out with just a factory block. So this one in particular was a late model, what we call a roller block, that's already set up for a hydraulic roller using the OEM setup and also a one-piece rear mainsail. So pretty easy combination to put together. 4030 bore and a 4100 stroke is what makes this displacement. So let's dig into some pictures and go over the build. Alright, so the foundation for every build is a well machined engine block. So we always take our engine blocks, try to get good cores, and try to find some that are just don't need a lot of boring, cylinder boring, but maybe even a touch hone or 30 over, 40 over, something like that. This particular block was a later model truck, 351 Windsor block, one-piece rear mainsail, as I discussed earlier, already set up for the factory OEM style hydraulic roller setup. So let's talk about just for a second the different machining processes. First, we have these baked and tumbled so that they look like brand new cast iron. The blocks are heated in an oven to basically solidify all the grease and everything that's on those, and then we hit them with a almost like a shot peen type process where everything is just hit and the cast iron looks brand spanking new. After that, they're pressure tested just to make sure there's no cracks or anything that would bleed off water. Mains are checked, magnafluxed, that sort of thing. So the machining processes, we at least hone the cylinders, and if you have a good hone with a torque plate, you can make the cylinders nice and round and straight without having to bore the block. That's good for some of the rarer blocks that you really don't want to take out, to an overbore. You just want to increase the bore size just enough to make the cylinders perfect again. Something like a 427 side oiler or some of the Cleveland blocks and stuff that we mess with, excuse me, have thin cylinders, and you really don't want to, be boring those things out as much as you can. The decks are squared. That means that they are made flat and straight and even on each end so that everything is perfectly parallel with the crankshaft center line. If you don't do that, there's a pretty good chance that one piston is going to be further down in the hole than another piston. That means your compression ratio is going to vary from cylinder to cylinder, and that's not good. Some of the factory blocks that I've dealt with can be 20 thousandths out from end to end. So for instance, number one cylinder would be at, just say for example, 0 deck, and number 4 would be 20 down or something like that. So we do that process to make sure everything is even keel across the faces of the deck surface. The mains are align honed to make sure that the main tunnel is nice and straight and on size. And then you get into the different touch-up techniques that we employ to make sure that the oiling systems are where they need to be and that sort of thing. A Windsor really doesn't need much. They are priority main oiling already. Just the oil pump mounting flange hole needs to be blended in, and a good bearing chosen. So as you can see here, block is fully machined and painted. testing some main bearings there, and probably getting ready to do my main bearing clearances. Custom hydraulic roller camshaft in this one. 50,000 striations are in the low 230s for this size engine, and you'll see where the peak horsepower RPM comes in a second, and how all that translates. You can also see from that picture that the bottoms of the cylinders have been deburred. So if you don't do that, you'll leave a sharp edge there, and the piston will drag across that, and then you'll get all kinds of nice, nasty marks up and down the cylinders, and a lot of metal transfer that you don't want. You can also see there that I used a billet core camshaft. 99% of my stuff is billet steel, and roller cam on this one, you can see it, and just a higher end, or that's what we're aiming for, is a higher end build. Here's a good shot of the rotating assembly going in. We used a Scat crankshaft, so 4100 stroke and a 4030 bore size on this one. You'll get a good shot of the pistons and the rods here in a second. ARP fasteners on the mains, and they usually come with a stud that you put on the passenger side of the block if you choose to run a rear sump pan with one of those long pickups that have to be supported. There's a good shot of the crank laying in the block, so you can see the main saddle, you can see the main bearing, and what I'm checking here is just to make sure that the bearing doesn't touch that radius, that fillet on the main journal on the crankshaft. That's a pretty important thing to check. We do that on both the mains and the rods. If you don't do that and you have a discrepancy there, the bearing will rub. It'll rub that fillet, and it'll eventually get the bearing hot. So you can see there, that's a rod journal, and you can see that the bearing is very far away from that rod journal fillet there. So you want that clearance, otherwise it'll rub, it'll heat up, it'll cause a lot of problems. We're going to look at the timing set next. I use basically coils on a lot of my street and race stuff. This is a a billet timing set with a 9-way adjustable crank gear. You can see how many keyways are in that crank gear. That allows me to dial in the cam timing in 2-degree increments. So it'll do a 0 advance retard, and then a 2-degree, 4-degree, 8-degree, that sort of thing, and then it'll go around and do it for advance. So we start at a what you would call a dot to dot reference on the timing set. That means 0 retard or 0 advance from the way that the cam is ground. Alright, here's a good shot of the piston and rod assembly. That's a Mahle piston. You can see there that it was meant for a 4030 bore size. It's got clearance built into it. The piston mics 4024 and a 6/10 there. Very lightweight stuff. I love Mahle pistons and rings. 437 grams on that piston, so very, very light, and uses a 1mm, 1mm, 2mm ring pack. Very lightweight. The thinner the ring pack, potentially the more force that the rings put on the cylinder wall, which can translate to better sealing and better horsepower. So thinner ring packs, much better. Looks like a Molnar rod there, and just an overall a very lightweight piston rod assembly. Once we get a piston rod in, we can degree the camshaft, make sure that the cam is stuck in there the way that it should be stuck in there. Now remember, we degree the cams to make sure that the crank, the timing set, and the cam all are working together. So it's never one part's fault. It's usually a combination, a tolerance stack of all three of those parts. So every cam that we use gets degreed. Make sure that everything is the way that it should be. Once you get it degreed and you get your cam timing set up the way that it needs to be, then you can check piston valve clearance. And I've done that many times on other videos, and in this particular instance we use some clay just so that we can see the radial clearance of the valve against the valve relief, and also the depth clearance of how high the valve ends up being above the piston. And as you can see there, plenty of radial clearance. You can see where that eyebrow is, that valve relief, and then where the edge of the valve stops. Alright, then we have an assembled short block. Nice looking piece there. The block is really clean, looks brand spanking new, and Mahle pistons and rings and rods, crank, cam, timing set all in the block. You can see there that this is a roller block. Those two bosses in between the lifter bores and the lifter valley are tapped, and they're drilled and tapped for the Ford OEM style lifter hold down tray. So the lifters are not link bar lifters. They have the little dog bones that keep them from rotating, and then you have the hold down tray to keep a force down on each one of those dog bones to keep everything happy. And I've ran that OEM style lifter setup to about 650, 660 lift. So they will actually do quite well if you have the right lifters. Some lifters are made with a little bit extra clearance. If the cam core, the base circle is wrong, or the lifter is not made correctly for that entire system, then at peak lift it'll start to raise the dog bones up, which is not good. So let's go over real quick on the rules of thumb for blocks and cam base circles. On a factory block that was not a roller block to begin with, you can either use a reduced base circle cam and drill and tap holes in the lifter valley for that OEM style hold down tray. So small base circle cam, OEM style, or you can use a small base circle cam or a standard base circle cam with a link bar lifter. On late model blocks that have been set up from the factory with the OEM style, you use a standard base circle, and you can use that with a OEM style lifter or a link bar lifter, or you could go to a small base circle cam with a link bar lifter. So you rarely have to go to a small base circle cam in a 9500 block. There's just a good bit of room in between the cam and the rods, so you generally don't have to see that occurring. And there's a good shot of the OEM style lifter hold down. You have the little dog bones in between each lifter pair, and then a sheet metal hold down tray that keeps everything from popping up and getting away from the correct valve action. For the cylinder heads, we went to AFR. These are 205cc Renegade heads from AFR. And the 205 heads are generally set up for a solid roller. So I ordered these bare with valves, and we set up the springs and everything for this hydraulic roller cam. AFR makes a great head. Love those heads. It's very, very hard to beat an AFR Renegade or a Trick Flow twisted wedge or high port cylinder head. Just really, really nice out of the box. You can see there that the valve spring install heights are all measured, and Viton valve seals are on there. There's a shot of the combustion chamber and the valves, stainless valves, I believe 8mm stems from AFR, so nice, lightweight, good parts. I usually totally disassemble all the heads if I get the heads in assembled. Make sure all the install heights are correct. Make sure that the valve spring loads are correct. I'll pour a combustion chamber to make sure everything is good in that direction, and then I can get a final number on my compression ratio. Before the heads go on, head gaskets obviously have to go on. These are Fel-Pro head gaskets, and Fords are they're picky on which way you put the head gasket on. So small block Chevrolet, doesn't matter how the head gasket goes on. Small block Ford, FEs, big block Fords, they have a front and a rear orientation that you have to follow, and it's mainly for those two big holes there on the rear of the gasket that you see. So heads are on, ARP head bolts, and everything's starting to look like an engine. And we use ARP adjustable guide plates and AFR adjustable guide plates and ARP rocker arm studs with a 7/16 stud for the rocker arms. So we're trying out the intake manifold gaskets, making sure everything lines up with the gasket and the intake manifold. Got some Harlan Sharp rocker arms on there to open the valves for us. And as always, intake manifold off. I always pre-oil, make sure everything is oiling the way that it should be. If you have to pull an intake manifold off, especially on FEs, it'll put a little bit of a damper on your day. So I try to stay away from that sort of thing. I've caught all kinds of problems by pre-oiling on the stand with the intake off. So always do that, and that's one of my biggest tips. Spin the oil pump with a drill. Make sure you get some good RPM in there, and make sure the oil pressure is good and it goes everywhere it's supposed to go. There's a fitment of the intake manifold. It's an RPM air gap. Really nice intake manifolds for street engines, both torque and horsepower. It's hard to beat an air gap intake up to a specific RPM range. Then our next shot is going to be a pretty much almost assembled engine, and it'll show the rocker arms being set, the intake manifold mounted, MSD distributor with the large cap. I prefer the large cap over the small cap. You get less spark scatter with the big cap. And we got our carb lift plate on there, and our Autolite spark plugs, harmonic balancer, and then won't be too much more to put our water neck on and our water pump and get everything back to that first picture where we showed an assembled engine. It's a good shot there. Black block with aluminum heads looks good. That's always a good combination. Romac harmonic balancer. Romac makes some good balancers, as does Power Bond. Use those two pretty exclusively. Trend push rods. So all high quality parts in this build. Wix oil filter, Canton oil pan, and I think it turned out for this customer that later on when he tried to put it in his vehicle that the oil pan hit the cross member, so he had to switch it to a Mylodon pan. But sometimes that happens. Full MSD distributor and spark plug wire combination there, and a Mylodon aluminum water pump. Alright, and for the moment that everybody's been waiting for, I've got a crumpled up dyno sheet. Dynoed this one about 4 years ago on July the 2nd, 2020. Starting at the left hand side, like we always do, we look at the oil temperature. No gains in there, a tenth of a degree or a couple hundredths of a degree. Dyno this one at about 150 degrees water temperature. Oil pressure went up throughout the pool. Air fuel ratios were pretty close, tight, side to side. This intake manifold was not ported, so the runners were not balanced. That's why you can see a little bit of a discrepancy on the air fuel ratios between side to side. Normally when I have Joe or another porter balance the intake manifolds, you'll see that airflow ratio pretty much stay neck and neck on both sides. For torque, next column over, 586 pound-feet of torque at around 4,300 RPM, 540 horsepower. So as you can see, all low RPM stuff, a ton of torque throughout the curve, and a ton of horsepower. And we're back to where we started with an assembled engine on the cradle ready to dyno there. Alright guys, these big inch Windsors make a ton of horsepower, and even with a factory block you can get some cubic inches. So I've seen about 434 cubic inches from a factory block combination. Obviously with an aftermarket stuff you can get way up past that, 470, 480 in some situations on displacement. So big displacement Windsors. They make a lot of horsepower. Thank you guys for hanging with me on this video. I do not have a dyno video. I'm sorry, the customer was there with me that day, and he videoed while I took care of everything else, so I didn't get it on my phone. So no dyno video on this one, but it is a torque monster with some good horsepower to boot. If you want to see more videos like this, make sure that you hit that subscribe button so that you don't miss out. Everything that I'm working on right now with current engine builds is in machinist jail or parts jail, waiting on parts. So can't show you anything new. I do know that Project Junkie Junk Jr., the heads, will be leaving for Mr. Joe on either Monday or Tuesday. All the machine work has been done on those, and bronze valve guides, valve job surfaced, all the good stuff changed over to a rocker arm stud combination. Spring pads milled down around the guide, so ready for some porting action, and got a bunch of more parts coming in for more builds, so stay tuned for all that. Subscribe so that you don't miss out. Hope you guys are having a good week, and may have another video or two for you this weekend. We're coming up on 10,000 subscribers. I think I'm in just the 20s left before we hit that 10,000 number. So thank you all for supporting the channel. Thank you for all that you do for me and for the Lykins Motorsports channel. Have a good weekend.